All right. Morning, boys and girls. Thursday, March 26, 2020. I'm in a good mood. I mean, technically, for me, it's Wednesday night because I'm filming this at night. But I'm drinking a big glass of orange soda. So I'm in a good mood. I also had pizza. So excuse me if I get a little bit of a food coma. But, all right, let's do some calculus. It's, 9 o'clock at night. So what better, what better time to do calculus than at 9 o'clock at night on a Wednesday night? All right, so let's do the first one. The limit as x approaches 0 for x squared minus 25 over x squared plus 4x minus 5. Well, when in doubt, your first move should be direct substitution. So I'm always going to do that. So if I plug in x equals 0, oh man, 0. But you never know. You never know. So I'm going to plug it in, and I'm going to get, well, 0 squared is 0. 0 minus 25 is, oh, you mean to tell me it's not 0 over 0? Oh, thank God. So I got 0. Well, I'm just going to put it right there. 0 minus 25. Okay, well, at least it's not 0 on the top. So let's go 0 squared. Okay, well, that's just 0. Plus 4 times 0. Oh, that sucks. 0 plus 0, and then minus 5. So this whole thing is literally just going to be negative 25 over negative 5. Or positive 5. Oh, my anxiety is at ease. Okay, cool. So the limit as x approaches 0 for x squared minus 25 over x squared plus 4x minus 5 is 5 because direct substitution just got us 5 over 1, or just 5. So what does that mean? The intent as x gets closer and closer and closer to 0 is that y also gets closer and closer and closer to 5. And that point 0, 5 actually exists. So this point is called continuous. Okay, but let's move on to problem number 2. Oh, the exact same function, but now the limit is going to be approaching x equals negative 5. So we're going to get closer and closer to negative 5, but not actually get to x equals negative 5, or so we think. So let's plug it in now. So in my noodle, I'm going to plug in x equals negative 5 and hope it doesn't hurt. So now I've got 25 minus 25 over 25 minus 20 minus 5. How anticlimactic. 25 minus 25 and then 25 minus 20 minus 5. Well, you know the drill. 0 over 0. So the difference between problem number 1 and problem number 2 is, well, direct substitution doesn't work. And yes, I'm crossing it out intentionally. I'm writing this down, but I'm making a note to myself that I'm not happy because there's a hole in the graph at x equals negative 5. So what do you guys want to do? Well, we're going to do this problem in both ways because I care about what your college professor is going to say when you get there. So the limit as x approaches negative 5, and let's say I want a factor because that's what you should be doing when you're in college. What's a derivative? I don't know. I'm just a really prepared 18-year-old. So let's just factor this top. X squared minus 25. Well, that's the difference of two squares. We have a pair of conjugates. So we've got x squared minus 25. So we are going to break that up into conjugates. X plus 5. X minus 5. Okay. And then the bottom, what two numbers multiply to negative 5 and add to 4? X plus 5, x minus 1. Aha. Now, oh, well, there's the problem. X plus 5 over x plus 5, that creates a hole in the graph at x equals negative 5. That'll be $400. So now, the limit as x approaches negative 5 for x minus 5 over x minus 1, noticing that I'm still writing down limit as x approaches negative 5 because I haven't plugged it in yet. Is it legal to plug in x equals negative 5 now? Yep. So I'm going to do that. So negative 5 minus 5 over negative 5 minus 1. So now I'm just going to move the notebook up. Negative 5 minus 5 is negative 10. Negative 5 minus 1 is negative 6. Can I simplify this? Well, first things first, a negative divided by a negative is a positive. And 10/6 can be reduced by dividing the top and bottom by 2. So this is going to be 5 over 3. So what does all this mean? As x gets closer and closer and closer to negative 5, y gets closer and closer and closer to 5/3, but at that point is not continuous because it's a hole in the graph. Okay. Moving on. Problem number 3. All right. Oh, same problem, but what's another technique that good old Matt is going to let you use? All right, factoring is hard. Why not use the cheat code? Hang on, let me take a sip of orange soda. L'Hopital rule. So L'Hopital rule states that if the limit as x approaches negative 5 creates 0 over 0, you have a top, you have a bottom, take the derivative of the top, take the derivative of the bottom, and hope that that problem goes away. So on the top, we've got the derivative of x squared, which is 2x. The derivative of negative 25, who cares? I just waved my hand. Sorry, I can't. Ooh. Sorry, I have the iPad on my left hand. I'm just like, wow, my right hand is really close to the camera. And negative 25, the derivative of negative 25 is 0. So I'm just going to let that be. And then, so the top is just 2x. The bottom is going to be 2x plus 4. And the derivative of negative 5 is gone. Now, is it legal for me to plug in x equals negative 5? Yeah, I'm going to plug it in. So I've got 2 blank over 2 blank plus 4. Excuse that long fraction bar. I just wanted to make sure I had enough space. I didn't do the problems in advance this time because last video I made a mistake, and I figured it'd be better to just go slowly with the process. I tried to rush it. And so even me with a bachelor's degree, if I rush things, it's not a pretty picture. So 2 times negative 5 is negative 10. 2 times negative 5 is negative 10, and I'm going to add 4. So that's still negative 10 over negative 6, or, you know what? Same thing. 5/3. Same thing. As x gets closer and closer and closer to negative 5, y gets closer and closer and closer to 5/3, but that point, negative 5 comma 5/3, does not actually exist. So therefore, x equals negative 5 is a discontinuous point. Ah, here we go. Okay, the limit as x approaches 0 for 1 minus cosine of x over x squared. Do you see why I waited to show you L'Hopital's rule to do a lot of limits? Because I know that I'm dedicating a lot of time with limits. Hopefully we'll have a test due Monday. So tomorrow will be the last review day, and then I'll hand you guys, I'll PDF you guys a test or Google share you a test. And yeah, you'll have the weekend and Monday to do it. So yay. Anyway, 1 minus cosine of x over x squared. I'm going to try, because it doesn't hurt to try, x equals 0. Well, if you know your unit circle, you'll know that at x equals 0, at 0 radians, yes, whenever you use trigonometric functions, you're going to be in radians. So it's going to be 0, it's going to be pi, it's going to be pi over 2, pi over 3, 3 pi over, and so on and so forth. But anyway, so the point is cosine of 0, if you plug it in the calculator, you're going to get 1. So this is 1 minus cosine of 0 is 1. All that over 0 squared, which is 0. Well, I mean, that's going to be 1 minus 1 is 0 over 0. So either way, sorry, it's not as neat. I'm holding the iPad in one hand. So it's a thought bubble. Either way, I'm not happy. Could I factor? Yeah, I hit the glass. I was trying to do the whole shake the hand and wave the hand around like in confusion and go, well, side to side. And then I hit the glass with my pen. So let's do the L'Hopital rule. So the limit as x approaches 0, hit the glass. The limit as x approaches 0. The derivative of the top. Let me make a thick fraction bar because I messed up. Anyway, so the derivative of 1 is 0. The derivative of cosine, so let's just break this up. The derivative of cosine is negative sine. But remember that there's a negative in front, so I'm going to put a negative right there. I'm doing this in 2 steps. The derivative of negative 1 cosine of x would technically be plus sine of x. So it'd be positive sine of x on top. So that double negative forms a positive, and the derivative of x squared is 2x. So in the end, I've got the limit as x approaches 0 for sine of x over 2x. Can I plug in x equals 0? Well, short answer is no. Because if I put my little thought bubble right here, and I do sine of 0 over 2 times 0, I got sine of 0 over 2 times 0. Sine of 0 is 0. 2 times 0 is 0. Wait, so I've got another 0 over 0. So what does L'Hopital rule say? If you get 0 over 0, take the derivative of the top and the derivative of the bottom until that problem goes away. In this case, I have to do L'Hopital's rule again. So now, once again, L'Hopital, I just put LH right there. So the limit as x approaches 0, please indicate that you are using L'Hopital. I like to put an LH above my equal sign. Some people literally like to put L'Hopital rule like right on the side as a side note, but anyway. So the derivative of sine of x is cosine of x. And the derivative of 2x is just 2. Now can I plug in cosine of 0 over 2? Yeah. First off, that 2 is a dead giveaway because it's not going to be 0 over 0. So now I'm going to plug in cosine of 0 over 2. And if you get your calculator out, cosine of 0 radians is going to be 1/2. So what does that mean? The limit as x approaches 0 of 1 minus cosine of x over x squared. I didn't succeed in direct substitution the first time, so it's automatically not a continuous point. I do L'Hopital's rule. What do you know? Plug it in. I still get a 0 over 0. I do L'Hopital's rule again. And I got a definitive 1 over 2. So as x gets closer and closer and closer to 0, y gets closer and closer and closer to 1/2. But the point 0, 1/2 does not actually exist. It's the intended point, but it's a hole in the graph. Okay, moving on to problem number 5. So let's say, flatten out there, paper. So let's say I got the limit as x approaches 3 for x squared plus 7 minus 3. Sorry about that. So I'm going to make that clear. Sorry about that, I wrote 7. See, this is why I shouldn't do the problems in advance, but luckily I caught my mistake. All right, so let's say I plug in x equals 3. So I get 3 squared plus 7, all that in the square root, minus 3 over x plus 3. Okay, well, the bottom is not going to be 0, so that's a good sign. So 3 plus 3, that's going to be 6 in the denominator. So that's 9 plus 7 in the square root, minus 3 over 6. So that's the square root of 16 minus 3 over 6. So that's going to be the square root of 16, that's going to be 4 minus 3 over 6, or 1/6. Okay, cool. So even though it's in my thought bubble, I like my thought bubble because it tests it out whether x equals 3 is a continuous point or not. If direct substitution works in the first place, and you get a y value, well, then yeah, the limit as x approaches 3 of all this nonsense is 1/6. That point actually exists. So it doesn't hurt to do a thought bubble if you, because I get scared when I see a limit and I see a top and a bottom. I'm honestly, I automatically think, oh, it's the worst possible outcome at 0/0. So it doesn't hurt to try. Okay. Let's try this one. Oh, remember absolute value? The limit as x approaches -3 for x plus 1 in the absolute value bars plus 3 over x. Is this going to be an indeterminate form? No. Absolute value is just going to, no matter what you plug in, it's going to be the positive equivalent or 0. And this is going to be 3 over x. Well, the only thing that would make me nervous here is if this x was 0. But remember, what are we going to plug in? We're going to get closer and closer and closer to -3. So, you know what? I'm just going to jump to conclusions and just plug it in. So I got the absolute value bar. I make it really thick because that's just who I am. So -3 plus 1. Oops. Oh, that's a 3. That was a smudge with a pen. Plus 3 over -3. So now, -3 plus 1 in the absolute value bars. So that's -2 in the absolute value. Plus, well, -1. 3 divided by -3 is -1. So the absolute value of -2, how far is -2 from 0? 2 steps. And then that's plus minus, that's -1. So, as x gets closer and closer and closer to -3, y gets closer and closer and closer to +1. And because direct substitution worked, the point -3, 1 actually exists. Okay. We're going to do 3 more problems. Okay. So we've got the limit as x approaches 1 for 7x squared minus 4x minus 3 over 3x squared minus 4x plus 1. What's my first move? Direct substitution. Always show direct substitution. So I'm going to plug in x equals 1. I love x equals 1 because 1 squared is 1, 1 squared is 1, 1, 1. Anyway, so I get 7 minus 4 minus 3 on top over 3 minus 4 plus 1. Well, 7 minus 4 is 3. 3 minus 3 is 0. 3 minus 4 is -1. -1 plus 1 is 0. So I've got an indeterminate form. Well, I know it's been a while, but can we factor a quadratic trinomial if the coefficient in front of x squared is not 1? So it's 7 and 3 right there. So can I factor the top? Yeah, I'm going to do that eventually, but you know what sounds really convenient right about now? My good buddy, L'Hopital. So I've got the limit as x approaches 1. And I'm going to take the derivative of the top. What is the derivative of the top? So that's going to be 14x minus 4. And what's the derivative of the bottom? 6x minus 4. Now can I plug in direct substitution for x equals 1? Yeah. So I'm going to do that. So I've got 14 times 1 minus 4. All that over 6 times 1 minus 4. So I'm going to plug in x equals 1. So that's 14 times 1. Well, that's just 14. And 14 minus 4 is 10. 6 times 1 is 6. Minus 4 is 2. So 10 over 2 is 5. What information do I get out of this problem? Well, as x gets closer and closer and closer to 1, y gets closer and closer and closer to 5. But that point does not actually exist because Isaac Newton threw a chair through a window. It's a hole in the graph. I'm going to come back to the factored version at the end because I want to get to number 8. That'll be number 9. Okay, so let's say I do number 8. I just want to keep your mind off of it. All right, so let's say I got this problem. Now, why do I love L'Hopital rule? Because it's a straightforward problem. In this case, if I've got e to the 0 power minus 0 minus 1 over cosine of 0 minus 1. So let's say I plug that in. E to the 0 minus 1 over cosine of 0 minus 1. So, well, anything to the 0 power other than a base of 0 is just going to be 1. So e to the 0 is going to be 1 minus 0. I'm just going to plug it in just because. So in the end, this is just 1 minus 1, or 0. And cosine of 0 is just 1. And minus 1 is 1. So I get 0 over 0. Could I factor? Yeah, I'm sure there's a way. But you know what sounds really convenient? Not factoring. You're right, L'Hopital. Not factoring is my favorite thing to do for a function that's not a quadratic. So I've got the limit as x approaches 0, and I'm going to take the derivative of the top. So, what do we got here? What's the derivative of e to the x? Well, I don't have to do chain rule. The derivative of e to the x is just e to the x. What's the derivative of negative x? Minus 1. What's the derivative of negative 1? 0. What's the derivative of cosine of x? Negative sine of x. And what's the derivative of negative 1? Well, it's just 0. So I've got e to the x minus 1 over negative sine of x, and I'm going to try to approach x equals 0. Do you think I can? So once again, I'm going to plug it in. E to the 0 minus 1 over negative sine of 0. So that's just going to be e to the 0 is 1 minus 1 over negative 0. Right? That's just going to be 0. Anyway, so the point is this is 0 over 0. I'm not happy here either. So what do you think I need to do? I need to do L'Hopital rule again. L'Hopital. The ultimate cheat code. So I'm going to do the limit as x approaches 0 for the top. The derivative of e to the x. What's the derivative of e to the x? E to the x. What's the derivative of negative 1? 0. Now, just cover that up really quick. Just put a negative in front. What's the derivative of sine of x? Cosine of x. And I'm going to put a negative in front. Right? Because imagine a negative 1 in front. If I've got a coefficient in front of a trig function, I can just factor out the coefficient and just take the derivative like normal. I don't need to do product rule. Now, could I plug in x equals 0? Oh yeah. So I've got e to the 0 power over negative cosine of 0. Well, let's just plug in what I know. The derivative, not the derivative. E to the 0 power is just 1. If it makes you feel better, put a negative 1 right here. What's cosine of 0? It's just 1. So in the end, this is just 1 over negative 1, or negative 1. So, our first move was to apply direct substitution. But did that work? No. So, when x approaches 0, it becomes discontinuous. I tried L'Hopital rule, didn't work. I tried L'Hopital rule again, it finally works. So now, as x gets closer and closer and closer to 0, y gets closer and closer and closer to -1, but the point 0, -1 does not actually exist. Okay? Because I want to prep you guys for college, I want to go back to problem number 7 and approach this as a problem that you can factor, because let's face it, your professor goes limits, a lot of derivative, and then an intro into Calc 2, and then your Calc 2 professor's like, hey, there's this fancy rule called L'Hopital's rule that your high school teacher is going to say, told you so. So how do I factor this? Well, I know that this is Algebra 2, I know this is pre-calc, but I figure I'm a nice guy, let's just factor the top. Remember that if there was no number in front of x squared, it's very, very easy. You just figure out what multiplies to c and adds to b. But since the coefficient in front of x squared is not 1, you have to figure out what multiplies to ac and adds to b. In this case, what multiplies to -21 adds to -4, right? That's going to be, you can pause the video if you want to figure that out. -7 and +3. You're going to split the middle term, factor by rectangle. So you got -7x, +3x. And remember that whole thing is 7x squared and -3, blah, 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 blah. So cover up the right column. You remember this, everything comes full circle. Everything from algebra to algebra 2 to geometry to pre-calc to what's your number? What can I factor out here? 7x. What can I multiply here? 7x times x is 7x squared. X times 3 is 3x. 7x times -1. So this whole thing factors out into 7x plus 3 over x minus 1. So why don't I just put that up on top right now. So the limit as x approaches 1 for 7x plus 3 times x minus 1. All right, step 2, I'm going to factor the bottom. What was the bottom again? 3x squared minus 4x plus 1. So why don't I just jump right into it? What multiplies to a times c? So that's 3 times 1, or 3. And adds to -4. Adds to b. Sorry about that. To b, which is -4. What are those numbers? Well, it has to be a negative-negative combination. So that works. Sorry about that. Let me just So now, the middle term gets split into -1x and -3x, leaving me with the following. So that's going to get 3x squared +1. That's going to be -1x and -3x. Either way, you do some factoring. What can I take out? And x, 3x, -1. It's all coming back to you, isn't it? 3x times -1. So this whole thing factors out into 3x minus 1 times x minus 1. And you'll notice, what's the cause of the hole in the graph? That x minus 1 over x minus 1 creates a hole in the graph. That'll be $400. Now, I've got the limit as x approaches 1 for 7x plus 3 over 3x minus 1. Now that the whole is gone, I'm going to plug in x equals 1. And now I've got 7 times 1 plus 3 over 3 times 1 minus 1. So that's going to be 7 plus 3, which is 10. 3 times 1 minus 1 is 2. I still get 5. So I'm going to fold my notebook out. Sorry about that. You'll notice that it doesn't matter which way you like. So I'm going to leave that choice up to you. Ignore the orange soda cup at the top. I don't know about you. I'm good at factoring, but I love me some L'Hopital. Your choice when the test is due on Friday. We'll have one more review day tomorrow. I just want to get you guys solid on indeterminate forms of 0 over 0. The next topic after this, I'm going to put some infinity into our limits. Hope. See you guys Friday. Have a good day.